So now you're going to begin to analyze that. So what you want to do now is you want to bring that into your analysis system and start looking for what it is that you were tasked to look for. So the key, and again, I hearken back to CSI, which I think is an excellent show, and insofar as it reflects the reality of the process, which I choose to believe it probably does. It's not terribly far off. I remember one scene where Grissom looked at the output of the mass spectrometer, which gave all of the elemental chemicals that made up the product, and he said, "That's pink lipstick," because he knew what all of those base things meant. And so, yeah, it's a disk, it's got a bunch of blocks here, and it's got a bunch of files here, but what does that mean? So the analyst who deals with this type of information knows the specifics of that stuff, what it means. Where, for example, when the user plugged in USB drives, that's recorded somewhere on the system. If it's Windows, it's recorded in the registry. There's a well-known place. So what the analyst knows are all those gross details of all of the stuff that's in there and can mine it to answer the questions. So I need to know all of these things about bad blocks, the host protected area that's not going to be part of the file system, but could have some good stuff. The file system specifics, there's, if you took, for example, the SANS forensics course, when I took it 4 years ago, they gave you an image of a thumb drive. That thumb drive had the file system perturbed or broken, is the right word, so that if you tried to mount that thumb drive, the system would say, I don't understand what this is, because they took some information and transposed it in the file system so it wouldn't look like a file system. But if you looked at it and understood the layout of the file system, you'd say, oh, these things are in the wrong place. You flip a couple of them back, and now you have a real-life file system. So the point is the intruder, the bad person, in this case the suspect, had encrypted by breaking the file system, in essence. And it was a simple transposition to repair it. And so the the analyst who's dealing with this knows what this stuff looks like, perhaps may know how to repair it, know how to recognize what's going on. And then there's all of this, lots of cell phones, and forensics is now important. I know how an iPhone works, or an Android works, or an iPad, how all that stuff is laid out, and I can do something with it. So you need to be able to then, now you're coming in with your Pelican cases, you got to put that stuff somewhere, and then you need to start looking through it. So there's a person who keeps Pelican case, uploads it to your system, and spends the week. Now you've imaged 100 terabytes worth of stuff. I need 100 terabytes worth of place to put it, and somebody's got to do that activity. The way this was done in olden days, like 2 or 3 years ago, was if you walked into a SCIF, a secure facility, you probably would see that each one of the analysts had a beefy PC with every kind of connection possible and a whole bunch of local disk space. And what they would do is take evidence drives, connect it on their beefy PC, start reading it in so that they could do analysis, then they'd get coffee, drink coffee, get more coffee. They were single-threaded, is my point. So the way in which we've come up with this is something called CCAP, which is the CERT Clustered Analysis System. And essentially what this is a large collection of analysis vehicles, realized as blade computer systems, all sitting on a very fast network to a whole bunch of disk space. So there's a way to introduce everything into that disk space, and then I can, while that's going on, I can log into one of these other systems and work and continue working on the case I was doing last week. And I can work on a whole bunch of cases at the same time. And oh, by the way, I don't have to be physically there because it uses network protocols, remote desktop, so I can be anywhere in the world and have a strongly authenticated and encrypted connection back to my analysis environment. So I'm not single-threaded. I can still get coffee and drink coffee, but I'm not waiting. I'm not doing it for that reason. So that's what's going on here. These are all Windows boxes. We have a couple hundred terabytes worth of disk space available. We have upload stations to speedily as possible upload information into CCAP. We can analyze it all over the place. We can work with our law enforcement partners, talk to them on the phone. This is what I'm seeing. This is what you're seeing. We're both logged in, looking at the same stuff. Okay? This is actually sitting over in the machine room in the SEI. Yes?
So if you're using that platform for analysis, and you were talking about things have to be able to be replicated.
Yes.
And so does that have any applicability there? If, like the defense wants to replicate, do they have to use
what
this
that
platform?
probably means is that we would go off and do it with whatever tools we choose to use, then replicate that in like FTK, and then say, in FTK we found the following. And there's actually a version of CCAP, something that's called CCAP Lite, which is smaller version where information is copied out of CCAP, put in CCAP Lite, and then we give, and we have done this, you give to defense specific laptops that have connections into the CCAP Lite, same idea, remote desktop, so that they can log in and analyze the data, but the data still lives over in our machine room, specifically for that case.
Are they acceptable to that?
Yes, and that has been used in some national cases, and that's fine and dandy. Everybody's happy with that kind of a scheme. So yes, good question. Some of us on the DIID staff may have the ability to use programming languages, either programming languages or scripting languages to do more detailed analysis. We may do that for our own benefit to find what it is that we're finding, but usually we will communicate that as to we found this with FTK, or another competing project is called NCASE, a commercial product, so that they can replicate that exactly with the tools that they most likely have. One of the things about CCAP is that we are analysis application agnostic, which means you want to use FTK, go right ahead. You want to use NCASE, it's there, go right ahead. You want to use the CERT Forensic Appliance, go right ahead. You want to use Perl under SIGWIN, under Windows Server 2003, it's there. So however you want to dance, we provide a mechanism that allows you to do that. Most other applications produced by people typically have only one of those interfaces. We choose not to restrict it so that the analyst has as many options available to them as they want. And that's one of the hallmarks of CCAP. So CCAP is this collection of boxes, 3 or 4 racks of stuff, remote desktop, strong authentication and encrypted communication channel, RSA tokens for access so that people can gain access to the system anywhere in the world. Realistically, you don't have to be in the office doing your exam, doing your analysis. You can do it at home, and we all have on several instances. So that's what CCAP is. So I've imaged it, I took it back, I loaded it up, now it's in CCAP. I can do whatever I need to do to gain access. I can share it amongst law enforcement organizations. Everything works the right way. Collaborative, scalable. When I started on this team 4 years ago or so, I think we had maybe 50 to 100 gigabytes worth of space. We now have over a terabyte or more. Maybe it's 100 terabytes at this point. I don't know. Point is that you never have enough space. We're in a position where we can continue to add more. And more analysis, what I call exam stations. I think there were 12 when I got here. There are now 30. And sooner or later, the network can only be so saturated. You can only get so many bits off the disk so fast, throw them across the wire to get them to machines, and then you have to replicate that whole environment. So, gee, what a simple goal. Do analysis. Easy, right? You look at the captured images, you begin to, the stuff that came in the Pelican case that you've uploaded into your system, you still have to do something with that imaged information. Usually that's going to go in a safe under lock and key. You're going to have some kind of an evidence custodian to deal with that, and you actually begin to do the analysis. The name of the show here is, I think it's In Plain Sight, where somebody is abducted. The paradigm of that show, almost in every transition to a commercial, is they update the timeline that said, we discovered that this activity happened. If you've taken the advanced incident handling class, and I've taught it, or Mark has taught it, or Robin has taught it, one of the early things we say in that class on the first day is timeline. It is rarely the case in the times that I've taught it that the teams have actually constructed that timeline. They wait until about Thursday and then go, oh, we should have made a timeline. Mark is smiling and Robin is smiling. We've both seen this. So construct a timeline, a very good way of tying things together, putting things in order so that you can at least focus on the right things in the right order. Because when all is said and done, again, this is forensics, which means this is going to end up in a court of law. You have to tell a story to a collection of people called jurors who are going to decide something. So you need to be in a position where you're telling them a story. One of the ways to tell the story is through a timeline. This happened, and then we're saying the subject did this, and then the subject did this, and then this happened, etc., etc. And the timeline is the vehicle for doing this. So let's cut through this and say, start by creating a timeline. Castle is another excellent show where they have a murder board, and there's a timeline, and they put people's pictures up there and evidence, one-stop shopping for the whole case. An ordered list of changes, what changed and when it was changed. One of the issues of what is called modified accessed and created or changed times, or MAC, not to be confused with the MAC address of a network card, this is MAC used a different way, is that only the last change is what's actually recorded in the file, in the information associated with the file. File may have changed 1,000 times, but it's only the last time that's actually recorded in the file system. It's important to know that. And all of these, the file was used, it's got the metadata, you can find all this information in that to construct your timeline. On the Cert Forensic Appliance is a tool that's called Log Digit 2 Timeline. And what that is a collection of scripts, Perl scripts, that know the format of the repository of time-specific information on a Windows box. For example, index.dat is the history file associated with Internet Explorer. I went to this website at this time. I went to this website at this time. So log to timeline can take that index.dat for a user and give you a CSV, a comma-separated file that you can import into Excel and then sort based on time. So I can build a timeline. Then if I interpose into that anything else that user could have touched, I can say the user did this, downloaded this file, because I have the modified access created of the files in their file system, and I can build a story. So that's one thing that the forensic appliance is good for. So find what you're looking for. Again, you're not fishing, you have a warrant, there was a trigger, you're looking for something. You're looking for counterfeit images, images of counterfeit money. You're looking for child pornography. You're looking for a MySQL database with credit card numbers in it. You're not just going, oh, gee, let me see what's on this system because I don't know what's here. You have an idea of what you're looking for. So you want to digest that file, that image that you've captured, into something that you can deal with. FTK is one tool that's good with this. NCase, the Forensic Appliance, has some tools on it. Forensic Appliance has SleuthKit and Autopsy, which are good for this. It also has PTK, which is another public domain, a la FTK, except this is built with Python, PHP scripts, rather, for doing all these kinds of things. So you find things that support your case that you can add to your timeline. This happened here. Here's the file that corroborates it, et cetera, et cetera. You're building your story. Now, there's lots of tools. We have them here. It's called Secure Delete. Now, the purpose of Secure Delete is you want to delete a file such that nobody can recover it. And you do that by overwriting it with stuff and obscuring it. That's a counter-forensic technique. So it would be nice to know, if I'm doing an analysis of a system, if the suspect who is using that system was savvy enough to buy some of this software to defeat my attempt to analyze their system. It may be the case that I figure, well, this is a really good person. There's, the recycle bin is going to have anything in it. Slack space is going to have garbage. I can save myself some time, but not even looking for what's not there. And those are tools that deal with that. Guess what? There's a whole bunch of them that are out there. Some of them do what they say they do. Some of them don't do what they say they do. Let the buyer beware. Snake oil is all around us. Here's the evidence eliminator is one. It says what it does. It's hard to see. As it was said, you can get a copy of the slides and read through that. But essentially what it does, secure delete. Delete evidence so that if somebody looks on your computer, they can't find anything. Here is another tool. It's called a Perio. And what it does is it looks through a suspect system for telltale signs of the presence of counter-forensic tools. It's nice to know what I'm up against before I do that analysis, because you want to do the analysis in the shortest amount of time, get the information to the legal side of the house so that they can do their thing. If they've used counter-forensic tools, you're not going to find stuff, don't bother looking. That's the purpose. This is another tool that's available on the CERT Tools website. Another thing you can do, normally when you image a Windows system, you then read it in and you look at that image. And you try to say, oh, I see this is in this folder and this is in this folder, so I can assume that this is what the desktop would have looked like had I actually sat in front of that computer. If you were to take that disk and put it in your own laptop, maybe it would work, your original evidence disk or a copy, hopefully a copy. You may try to run it to see what's there. Well, it's going to change things. And so you got to go image it again and try again and image it again each time. There is yet another tool on our website that's called Live View. What Live View does is it takes a system, an image of a system, and it turns it into a VMware client. And then you can run it. But every change to that original image is held on the side so that you can easily go back to the original image that you started with. If you know VMware, you may know these as snapshots. So it does an initial snapshot of the system, then you can run it, and you can always go back to the beginning of the time easily, so that you can actually run the system, no matter what its hardware is, because it converts them into VMware devices. You can run that. Again, you can do it in CCAP or on any other system, and see what the suspect user would see on their desktop, and run the tools as they would run them. You don't know the passwords, you say? Fear not. Live View in the law enforcement version will go into the system, into the right places on the Windows system, and nicely zero out those passwords, making accounts having no passwords. So you don't have to worry about that if you have the law enforcement version. So now I've captured it, I brought it back, son of a gun, I'm actually running it. I can actually see what the user, whomever, would have seen on their desktop, and I can see what tools they have. I can go through and say, oh, that was an encrypted container. Maybe their credentials are actually saved. And if I double click on that encrypted container, it starts up TrueCrypt. And son of a gun, it's because it's got the completion of the captured information. It's got the login and password used to decrypt that container, because I'm logged in as that user as though it were their computer. Understand what I'm saying here? So it can save me an awful lot of analysis time. So Live View is another tool that's out there. I've used it. It can save a great deal of time and reduce an amount of guesswork. You just run it. And there's no downside to running it. It's as easy as 1, 2, 3. Select your device, set some parameters, click Start, and bingo, you're up and running, and you can do it over and over again to repeat it. So Live View supports these versions of systems. It's basically Java-based in its creation mechanism that actually gives you a VMware client out the other end. So that's part of my analysis. So analysis is an iterative process. You find something, put it on your timeline, leads you to something else. Again, TV is reflective of this and how this goes. Although with television, you can usually look and see where your DVR is. Oh, this is the first 10 minutes of the show. That's not the person who did it, because you have an idea of how these shows are written. You wait until about 37 minutes because each 60-minute show is about 42 minutes and change. Get to about 37, 38 minutes. This is probably the person who did it. And unfortunately, when you're doing this analysis, you don't have a clock where you can say, yep, 38 minutes, I'm getting close. It doesn't quite work that way, et cetera, et cetera. Again, you want to keep track of everything you find, document each finding. Now, if you use FTK, and EnCase works the same way, you have these things called bookmarks. Yep, that's important. I want to keep that as a bookmark. I don't know how important it is, but I'm going to keep it as a bookmark. And it happened on Tuesday. Oh, and this is a book. And then they did this. Oh, and they did it on Wednesday. So as I go through and find stuff, I can keep track of it in a way that makes it easier to put together my eventual report. And again, it should be repeatable. That's why we use whatever techniques we want, but then we usually replicate them in tools that law enforcement has so that they can replicate that. Because to say, for example, yes, I wrote a Perl script that did this, may not be of benefit to a defense team where Perl is a kind of, bauble on an earring. May not mean the same thing. So as I say, knowing what these things are, knowing how computer systems work is very important. I have found personally that because I have learned more about this, that I'm a much better system administrator because I actually understand how the system works better, because I can look at it from an analysis perspective and say, oh, this is how file deletion works. I didn't need to know that before. File deletion, classic example, anybody ever been into a library? The one with books? Okay, there's the card catalog, usually at the entrance to the library that tells where all the books are. Okay, so if somebody went over to the card catalog and took out the card, is the book still in the library? That's how file deletion works. The file's still out on disk, but the ability to find out where it is, the directory entry through the card catalog, is no longer there. If you know how the library is laid out, you can say, oh, this is 19th century classical literature. You can go over there and do a search until you find what you're looking for. So that's how file deletion works. Okay, that's important to know. Now we know how secure deletion not only removes the card, goes over to the rack, picks out the book, and destroys it. That's secure deletion. So as I say, you become a better system administrator when you do some analysis because you understand how your systems work. And that's Grissom saying that is pink lipstick, because he knows that those constituent elements make that product. So analysis is looking for what you're looking for, and you need to know what that is. Again, it's important to write it down, because eventually what you're going to have to do is you're going to have to write a report that says, I did this, this is when I did it, this is what I found. And somebody then takes that into a criminal setting and says, you did this, this is when you did it, and this is the impact, and that's why you're being charged. And occasionally, the analyst may get called on to say, this is how I did it as a witness. And there are some tools and techniques for doing that. CryptHunter, Apereo, the appliance, LiveView, and CCAP.